Hello, my name is Josh Obrecht, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Stream Reach and Catchments tool. This is the third tool in the Stream Network and Catchments section of the ACPF Toolbox. If you're on this third and final step of developing a perennial stream network, that means that you have delineated your flow network using the area threshold, and you have manually populated the stream type field. If we do not take the time to code our perennial network, then this tool would consider every single flow path a part of our stream reach, which is inappropriate. So we went in and coded our perennial network using a value of 1. All other flow paths were given a value of 0. When we run this tool, we'll be making a sub-selection to create the stream reach based on a stream type value of 1. This will give us an accurate stream reach. This is going to be the feature class that we use in all future ACPF tools when that tool asks for a stream reach. We are back in ArcGIS Pro. We have our stream network symbolized as our perennial network, coded 1 in dark blue, and all other ephemeral or intermittent or ditches, coded 0 in light blue. We will now run the Stream Reach and Catchments tool. We will open the catalog window if it isn't already open by clicking the Catalog tab on the right side of our window. We will expand the ACPF Toolbox and the Develop Stream Networks and Catchments drawer. We'll double-click on the third tool, Stream Reach and Catchments, to open it. There are 5 inputs. The first input is asking for our flow network. This will be the network that contains the edited stream type field. So we will choose that layer from the first dropdown. Once this has been chosen, it will populate the second and third inputs with our flow direction raster and our fill DEM, both from our ACPF Geo database. The fourth input states create stream reach and catchments from a subset of flow segments. We can also see that it states field name. For this input, we will choose stream type from this dropdown, as that is the field we edited for perennial streams. When we choose stream type, the dropdown under classification value activates. If we click this dropdown, we are presented with the values from the stream type field, 0 and 1. We will choose 1 as we are wanting our stream reach to be the segments coded 1. The next input asks for pour points. Since we have pour points, we will select them from the pour points dropdown. Our 2 outputs will be our stream reach and our catchments layer. We'll go to the bottom of the window and click Run. I just want to go over real quick what the output is going to look like. We will get our stream reach, which is each of the individual stream segments. With each of those segments, we will get a unique catchment associated with it. Each segment can be linked to its catchment by the link no field in the stream reach and the grid code within the catchments. Since each individual segment gets its own catchment, we can obtain strange, small, little catchments that are in between segments. That is perfectly fine, as that is the actual drainage area for the particular segment. The catchments layer is valuable because it can reveal discrepancies between the old and new watershed boundaries, which we'll see in a moment. The Stream Reach and Catchments tool has finished running. I have done some reorganizing of the table of contents and changed some symbology. The first thing we will notice is that our stream reach in light blue is identical to our area flow perennial streams. We also have our new catchments output, which we can see behind the stream reach. Let's take a look at the stream reach feature class. Right-click on our stream reach feature class in our table of contents and choose attribute table. We have a lot of fields associated with our stream reach feature class. Some of them will be very valuable. We have our drop value, we have a slope value, we have a segment length, our stream order for each segment, but probably the most valuable one, as stated earlier, is the link number, which is a unique identifier for each stream segment. If we open our attribute table for our catchments, we have a field called grid code. These grid codes will match up with the link numbers seen in the StreamReach attribute table. We'll be able to see all of our individual catchments if we symbolize our catchments by the grid code field. Right-click on our catchments layer in the table of contents and choose Symbology. In the Symbology window, we'll change our primary symbology by choosing unique values from the first dropdown. For field 1, grid code should populate, but if it doesn't, you'll want to select that from the dropdown. For color scheme, we'll choose red, blue, 8 classes. We'll need to add all of our values from our catchments table, so we will click on Add All Values within the Classes tab. If we zoom in and move around, we can find smaller watersheds, such as this light blue one, which is associated with this small stream segment. It may seem kind of strange to break down the watershed like this, but it can be valuable to understand where the flow is specifically going to which segment. All of the catchments combined constitute our new watershed boundary. I have changed the symbology to be a hollow orange color, and we will compare it against our old watershed boundary in yellow. These match up fairly well, but has some areas where the new watershed boundary is pretty different than the old one. In these cases, we will want to evaluate why there are differences between the two. When I am running a watershed, I will go around the whole watershed looking for larger areas and then bookmarking them. This allows me to make any changes, and when I rerun the tool, I only need to focus on those areas to see if my changes worked. We will look at some of these areas. If we go down to our southeast portion, we will turn on our hillshade. If we compare the boundaries, our orange boundary for our new set of catchments, the boundary is pretty far inland from our old watershed boundary. If we take a look at the imagery, we can see that there's a set of wetlands. The hillshade does seem to show that the flow does leave the watershed and come out through this little outlet over here on this side. In this case, this is something where we may just want to leave it because the landscape does in fact seem to want to flow outside of the boundary. This is just going to have to be your decision when you take a look at it. So utilize all of the resources that you have. We will go take a look at another one. We have our boundary, which appears to be on a road, and we have our yellow inside boundary, our old boundary. If we turn on the depth grid, this will show that it appears that we may have missed a couple of cuts in this area. If we turn on our cuts, we can see that in fact we did miss cuts in this area. I have gone in and added these cuts into these two areas and rerun the tool. If we take a look at the catchments after putting the cuts in, we can see that the catchment's boundary is now more closely aligned with our old boundary and is acceptable for what we want. One thing to keep in mind, if you have to add in cuts to adjust your catchments, you will need to go all the way back and rerun the 3-step process that is within the DEM preparation tools, starting with the manual dam builder tool. You will also need to go through the flow network process, including coding your perennial streams as once. One thing that we need to discuss when we're talking about catchments is when you have an input pour point. When you have an input pour point, a catchment above upstream for that pour point will be added. We have our input pour point here, and we can see that there is a catchment for that pour point that is outside of our boundary. We do not need that catchment, so that is all right to just go ahead and remove from the data set. It will not affect any of your data. Also does not have anything to do with your current watershed, so it's probably a good thing just to get rid of it. We've officially developed our perennial stream network and can move on to start citing conservation practices within our watershed. We've finished all the big manual editing processes associated with hydroconditioning our DEM and developing the stream network, unless there are water bodies in your watershed. From here on out, it's smooth sailing. To recap, we discussed and ran the Stream Reach and Catchments tool on our perennial stream network to create a stream reach to be used in all future tools. The next video will merge our stream reach with a water bodies layer.